Imagine a world where growing old is not an unavoidable destiny, but a real choice. Picture yourself with the power to press pause, or even rewind, the relentless clock of aging. This vision, once confined to myths and science fiction, is now inching toward reality. Thanks to a groundbreaking scientific leap, humanity stands at the edge of a transformation that could redefine not just medicine, but the very fabric of human life itself. Yet, with every stride toward life extension, society is confronted by a cascade of moral, social, and economic dilemmas that no one is fully prepared to answer. Let's start by understanding what aging really means. For centuries, the quest for youth has tantalized everyone from emperors searching for the fountain of youth to modern billionaires funding cutting-edge laboratories. But aging is far more than just wrinkles, gray hair, or aching joints. At its core, aging is the gradual, silent breakdown of the very cells that make up our bodies. Over time, the machinery within our cells falters. DNA accumulates tiny errors, telomeres at the ends of chromosomes shrink, and crucial molecular systems like NAD+, which power our cellular engines and repair crews, begin to dwindle. These changes don't just make us look older, they open the door to chronic diseases like Alzheimer's, heart failure, diabetes, and various forms of cancer. In essence, aging is the single greatest risk factor for nearly every major illness that plagues humanity. Modern science has made remarkable progress in decoding the biology of aging. Perhaps you've heard of the Yamanaka factors, a set of 4 extraordinary genes discovered by Nobel laureate Shinya Yamanaka. These genes possess the uncanny ability to transform ordinary adult cells back into a pluripotent, youthful state, meaning they can become any type of cell in the body. This discovery astonished the scientific world and laid the foundation for regenerative medicine. Suddenly, the dream of rejuvenating aged tissues or even growing entire organs in the lab seemed within reach. But there was a dreadful catch. Activating these powerful genes in adult cells doesn't just erase the marks of age, it also strips away the cell's identity, turning them back into stem cells. This process unleashes a risk of uncontrolled cell division, which is the very hallmark of cancer. As one leading researcher famously put it, roughly 90% of all cancers hijack the same genetic pathways we manipulate to reverse aging. The result? A high-stakes race to find a safer, more precise way to slow or even reverse the aging process, without opening Pandora's box of tumor formation. Over the past several decades, researchers have experimented with everything from calorie restriction, shown in animal studies to extend lifespan by up to 40%, to drugs like metformin, which appears to tweak the body's energy metabolism, and novel molecules such as nicotinamide riboside, a precursor to NAD+. Some interventions, like the use of rapamycin in dwarf mice, have delayed aging on the molecular level, resetting so-called epigenetic clocks. Plasma therapy, in which the blood from young donors is transfused into older individuals, has tantalized scientists with hints of cognitive improvement in early Alzheimer's trials, though the approach is mired in controversy and raises thorny ethical questions about equity and consent. Amid this flurry of innovation, billions of dollars have poured into longevity research. Tech visionaries from Silicon Valley, major pharmaceutical giants, and top public universities now compete to uncover the next big leap. It is within this context that a small but ambitious British biotech, Shift Bioscience, claims to have achieved a breakthrough that could rewrite the rules of the game. Their discovery centers on a novel molecule dubbed SB000. According to Dr. Daniel Ives, Shift's CEO, this compound may be the safest and most effective tool yet for cellular rejuvenation. Here's why. Unlike the Yamanaka factors, which risk pushing cells into a dangerous, identityless, pluripotent state, SB000 seems to rewind the cellular clock without erasing what makes each cell unique. In laboratory studies, the molecule rejuvenated cells on 2 major fronts: the methylome, which is a chemical code layered onto our DNA that governs aging, and the transcriptome, which determines which genes are turned on or off. Both of these are considered hallmarks of youth and health. Even more importantly, SB000 accomplished this without any evidence of transforming cells into stem cells or triggering the runaway proliferation seen with earlier methods. Dr. Ives calls it a major milestone for the entire field. The company's dataset-driven approach, which harnesses the power of artificial intelligence to analyze vast troves of cellular data, has enabled them to pinpoint targets other researchers missed. They believe SB000 could lead to safer, next-generation therapeutics for a whole spectrum of age-driven diseases, neurodegeneration, cardiovascular disease, diabetes, and perhaps even cancer itself. Early results are so promising that Shift is now advancing to proof-of-concept studies and plans to publish a series of papers as they peel back the hidden layers of cellular aging. But can one molecule really deliver on a dream that has eluded humanity for millennia? Skeptics abound. Some scientists warn that nature fiercely guards her secrets. Even if we can unlock the mechanisms of aging, there may be trade-offs we cannot yet see. For example, some interventions that lengthen life in one species do not always work in another, and effects that look miraculous in a petri dish or mouse may vanish in the complex environment of the human body. Others worry that even a partial success could trigger a new era of inequality, where the wealthy and powerful have exclusive access to extra decades of healthy life, further widening the chasm between rich and poor nations, and even between generations within the same country. This brings us to the central question. If we truly gain control over the aging process, what comes next? What would happen if SB000 or a similar molecule truly delivers on its promise? Imagine a future where aging itself becomes optional, where instead of dreading the decline of body and mind, people look forward to decades of vigor, clear thinking, and independence. If SB000 proves safe and effective in living organisms, not just in the lab, millions could enjoy dramatically extended health spans. This is not simply about adding years to life, but life to years, less dementia, fewer heart attacks, and a reduction in frailty that now burdens families and healthcare systems worldwide. Consider the scale of impact. In the United States alone, chronic age-related diseases consume over 3/4 of all healthcare spending. Globally, the costs run into trillions of dollars. What if most cases of Alzheimer's, arthritis, or cardiovascular disease could be postponed by 1 or 2 decades? What if the average person could remain active and independent into their 90s or even past 100? But with each opportunity comes profound challenges. Experts like Dr. Tony Weiss-Correa, a pioneer in aging research, caution, the promise of cellular rejuvenation must not become the privilege of a few. Societies must grapple with questions of access. Who gets these therapies? Will they be reserved for the wealthy, or will governments ensure broad, equitable distribution? If these treatments are expensive, will insurance companies or national health systems pay for them, or will millions be left behind? There are also deep ethical dilemmas. If people routinely live to 120 or more, how will that reshape society? Will retirement ages need to be pushed back? Will pension systems collapse under the strain, or will older adults contribute longer and reshape the fabric of the workforce? What happens to family dynamics when several generations are simultaneously active and healthy? Could population growth accelerate, straining resources and the environment? Or might longer, healthier lives inspire people to have fewer children, balancing demographics? Even more unsettling are the risks we may not see for decades. Every major advance in medicine has brought unintended consequences. When antibiotics were first discovered, no one foresaw the crisis of resistance that would emerge. The same could happen with anti-aging therapies. What if rare, slow-developing cancers or immune dysfunctions only become apparent after tens of years? As Dr. Ives reminds us, every great medical leap has come with risks we only understand in hindsight. Therefore, the path from laboratory breakthrough to safe, widespread use will require rigorous, transparent, and long-term studies, first in animals, then in carefully monitored human trials. On the bright side, SB000 is only one part of a global renaissance in anti-aging innovation. Across continents, scientists are testing everything from NAD plus boosters in Japan to plasma therapies for Alzheimer's patients in the United States to advanced gene editing tools like CRISPR-Cas9 that may one day repair age-related DNA mutations at their source. Researchers are also exploring R3 strategies, rejuvenation, regeneration, and replacement, as pillars of regenerative medicine. In some cases, combining cancer drugs has already extended the lifespan of mice by as much as 30%, raising hopes that similar combinations could translate to people in the future. Artificial intelligence and big data are accelerating this revolution. By scanning millions of genetic and cellular records, AI-driven platforms can identify new anti-aging targets, predict side effects, and personalize therapies to individual patients. The goal is to shift the entire field of medicine from simply treating disease to actually preventing the underlying causes of aging itself. But what does all this mean for you, right now? While molecules like SB000 are not yet available for consumers, the research signals a clear message. Healthy aging is becoming more controllable, and knowledge is your most powerful tool. Decades of studies show that lifestyle interventions, such as moderate calorie restriction, regular physical activity, and protecting your DNA from environmental damage, remain foundational. For example, calorie restriction has been shown in animal studies to extend lifespan by up to 40%, and regular exercise is linked to longer telomeres and improved cognitive function. Emerging research suggests that even common drugs like metformin, widely used for diabetes, and supplements like nicotinamide riboside, now being tested in clinical trials at institutions like Chiba University, may support healthy aging. However, experts stress that these are not miracle cures. Rather, they are tools in a broader strategy to extend health span, not just lifespan. As new therapies move from laboratory benches to clinical trials, it is vital for the public to stay informed, ask questions, and engage in the ethical debates that will shape how these technologies are used. The choices society makes today about how research is funded, who has access to new treatments, and how safety is monitored will determine whether the benefits of longevity are widely shared or reserved for a privileged few. And remember, safety must always come before hype. The most promising molecules, including SB000, will face a long, careful path of in vivo testing, first in animals, then in increasingly complex human studies, before any of us see them in hospitals or clinics. Even after approval, ongoing surveillance will be needed to catch rare side effects that only appear after many years. So, can SB000 revolutionize aging as we know it? The candid answer, it just might. Early laboratory results are stunning, showing that it can rejuvenate cells without the cancer risks that have plagued other methods. But the true revolution will only come if its effects are confirmed in living organisms, and if society navigates the coming wave of ethical, economic, and social challenges with wisdom and compassion. As a fascinating side note, scientists have already managed to extend the lifespan of laboratory mice by combining certain cancer drugs, pushing their life expectancy upwards by nearly 1/3. If such dramatic results can one day be replicated in humans, we may be on the threshold of a new era, not just of living longer, but of living better, with more purpose, vitality, and connection. If you are excited to keep your finger on the pulse of the world's most groundbreaking discoveries in global economics and technology, make sure to subscribe and tap the bell icon. What would you do with another healthy decade or two added to your life? Would you pursue a new career, travel the world, spend more time with loved ones, or reinvent yourself entirely? Share your thoughts and dreams in the comments below, and stay tuned for our next deep dive into the future of life itself.